In this video I'm going to do an explanation of bivariate data. Bivariate, bi meaning two, variate meaning two variables, two things that we're going to be measuring. Now if you look here, I've got the Premier League, the English Premier League table from last season, and if you note at the top here, the winner is Liverpool. There's no reason for me to highlight that except for that's my team. So here's the name of the team, the matches played, so they all played 38 games, wins, draws, loss, goals for, goals against, goal difference, which is goals for minus goals against, points, and the final position. You see, so every team has 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces of data attached to that team. So I guess you could say this is monovariate, meaning 9 variables, but we're only going to look at 2 because 2 is what we can graph. And again, I'm going to be using NZ Grapher, and the link will be in the description. Okay, with that said, what would we want to see? Let's have a look at the relationship between let's see, the number of games that you win and the number of points that a team gets. So the best way to do that is using a scatter graph. So if we go down here to graph type, I'm going to go to scatter graph, and it's going to give me an error. There must be another numerical value. There must be 2 numerical values, and I'm going to say the wins along the x-axis and the number of points on the y-axis. And what we see here is the scatter table, and it's automatically given me a line of best fit. So this is a line that goes between the points here that explain the data. And up here it gives me a sort of a brief summary. N is 20, so there are 20 teams. So each of these dots is a team. It is quite a good feature. You can hover over one of the dots. So this dot is Tottenham, this dot is Fulham, this dot is Nottingham Forest and Aston Villa, and right at the top here, as per normal, is Liverpool. And you would expect that, wouldn't you? The team that wins the most games tends to get the most points. That would make sense. There's a direct correlation. There is a positive correlation. So positive correlation means that the more wins you have, the more points you have. So it's going kind of upwards from left to right. Is this relationship a strong relationship? Yep, pretty strong. And we can see that from the R. The R is like a measure of how well this line, the line of best fit, fits this data. So all of these points are fairly close to this line of best fit that it's given me here. Okay, so that's interesting. It's not really groundbreaking. Let's have a look at something else. So let's have a look at how the number of losses. So along the x-axis now is the number of losses that a team has on this x-axis, and on the y-axis up here I've got the number of points. So I've got this column here on the y-axis and this column here now on the x-axis. And now something is different. Now it's a negative correlation. So in other words, the more losses you have, the lower number of points you get. And again, that shouldn't really be groundbreaking, if you lose lots of games, you're not going to get any points. You get 3 points for a win, no points for a loss. And here we see, again, there is a fairly strong correlation. The R is minus 0.96. The closer to 1, to negative 1 or positive 1 this is, the more, the better that this line explains these dots. And again, every dot is a team. So this team down here would be Southampton, wouldn't it? Southampton, so Southampton won. Southampton lost 30 games. Wow. That would be awful being in my life. So Southampton lost 30 games and they only got 12 points. I think they were pretty close for the least number of points ever in the Premier League. It must have been absolutely dreadful in their home ground towards the end of the year there, if anyone showed up. And at the top here is Liverpool. So surprisingly, kind of surprisingly, the team that won the most games also lost the least number of games. Okay, negative correlation, good correlation. There we could be fairly confident if we were to make some predictions using that it would work if we did a hypothesis test. Okay, let's look at what can we look at? Wins and losses. So along the x-axis, I'm going to put the number of wins, and along the y-axis, I'm going to put the number of losses. And again, we see this negative correlation, which kind of makes sense. So that tells us that if you win lots of games, you'll also lose not many games. And right up here is Southampton. Southampton lost a lot of games. This is the y-axis, and they didn't win many at all. And down here at the other end of the table is going to be Liverpool. So not only did Liverpool win lots of games, they lost not many games, because you can win, lose, or draw. Is the correlation strong? It's reasonably strong. It's reasonably strong, but notice it's not quite as strong as the other ones. Okay, let's have a look at the number of draws versus the number of wins. And now we see, okay, there's a negative correlation, but notice what's happened with these dots. These dots are all over the place. Okay, it's not a very strong relationship between the number of draws and the number of losses. Right up here is Southampton, of course, the most number of losses, but they also didn't lose many games. They also didn't draw many games. So it was either win or loss, mainly loss. And down here is Everton. Okay, so Everton drew lots and lots of games, and they didn't lose many games. So there's a negative correlation, but a very, very weak correlation. Alright, is there a relationship between the number of goals scored and the number of goals conceded? So goals for is the number of goals that a team scores, and goals against is the number of goals that a team concedes, that get scored against them. So let's have a look at that one. Goals for and goals against. And yep, so here we see something kind of interesting. It's not the strongest relationship ever. These dots are kind of scattered quite wide. But we see that if a team concedes lots of goals, GA is goals against, they don't tend to score many goals. So this tells us that teams that had good attacks also had good defense. So the big clubs like Liverpool, Arsenal, Man City, these big clubs that could afford really good attackers and really good defenders, tended to be strong everywhere on the field. But the correlation isn't that great. It's 0.72, which is, I mean, it's reasonably good, but you would expect that to be stronger. So the team that scored the most goals also conceded a few goals. So this team here, team 2, scored a lot of goals, but they also were quite miserly. They had the tightest defence in the league, and it was Arsenal, and it is one of their big problems. They have a really good defence. They just can't seem to score lots of goals. So if you were the owner's manager of Arsenal there, you'd be saying, okay, well, we don't really need many defenders, but we really need someone who can score goals. And just looking at the news, they have actually got out and bought some pretty good attacking players who can actually put the ball into the goal. Okay, let's have a look at goals for. So is there a relationship between the number of goals that you score and your final position? So in other words, if you were scoring a lot of goals, is that going to give you a good position? Well, yep, it does. There's a reasonably strong relationship here. So let's explain it. So the teams to the left here, the teams on the left here would be the top teams. So the team that comes first is going to be Liverpool, and their position is 1. And they also scored the most goals. So this team here scored a lot of goals, but they didn't get many wins. Tottenham had a terrible season. So they scored quite a few goals, but they must have also conceded quite a lot of goals, and we can see there that, their goal difference is -1. So they scored 64 goals, but they also let 65 goals in. So again, if you were the owner of Tottenham, you would say, okay, so we've got some good goal scorers. We need to go out and tighten our defence. We need to go buy some defenders, bring in some better defensive coaches, really concentrate on that. Because unless they get that good, they're not going to be any good at all. And they scored pretty much the same number of goals as these teams here. So if they tighten up their defence, they would have been around about mid-table there. 8, 10. Even here, Chelsea scored exactly the same number of goals, but because their defence was good, they won more games. What's the correlation? The correlation is negative. So the worse a team gets, the less goals they're going to score generally. And the correlation here, 0.84, forget about the negative bit, 0.84, it's reasonably close to -1. So it's a fairly good correlation. Is there anything else which might be interesting? Let's look at the goal difference. So the goal difference is goals for and goals against. So really this is the key stat that you'd be looking for, the goal difference and the position. Let's look at that one. So here we see a really good correlation. So in other words, if this doesn't really tell us much, but it is interesting to look at it. If you score lots of goals and don't concede many goals, you're gonna win the league. And really that shouldn't be amazing. But we see how strongly this works. And down here are the 3 teams that were relegated. So the 3 teams that were relegated were really bad. They were well behind the pack. So Southampton here, they scored 26 goals all season. I think Mo Salah from Liverpool actually got pretty close to himself scoring as many goals as Southampton, and they conceded 86 goals. So yeah, again, it would have been a pretty miserable season if you're a Southampton fan. And up here, Ipswich, the second worst team in the league, again, they only scored 36 goals, but they led in 82 goals, and you can't really do that and expect to stay in the Premier League. So these are some pretty awful teams. So if you're a manager looking at these teams, this stat is not really going to be useful. It doesn't really take a genius to work out that if you score lots of goals and don't let many goals in, you'll probably do pretty well. And that's a rough introduction of bivariate data.